Kia ora Year 12. This is question 9 from the Pure Maths 3 paper from November 2016. It's the complex numbers one. So here are the two questions. Don't watch this until you've had a really good try on your own. So just use it to check how you've got on and how to start. All right, so the first part is an equation solving. But the equation has got complex coefficients, which means we're not going to end up with conjugate roots. But we will end up with two solutions. So the way I'm going to do this is just using the quadratic formula, and I'm going to proceed as usual. I'm going to figure out A, B, and C and go from there. So I'm going to do the next part without too much talking. Then we're going to come back and look at the locus question after that. Okay, so all I'm doing here is substituting in a whole lot of coefficients, but you should be able to start to see that we've got one number times its conjugate. So this top bit here is going to end up not being a complex number. It's just going to be a real number, so that's good. And it's going to turn out to be a perfect square. And you can see, looking ahead, we're going to need to do something with the denominator being complex, so we're going to rationalise the denominator by multiplying by the conjugate. Right, so cleaning that big mess up, here's what we've got for W. We've got -4 plus or minus 16 plus 4 times this over 2 times 1 plus 2i. Now you can take out the 2 and split it into bits if you want. I'm just going to leave it all as 1. So here we've got 16 plus 4 times, well, we've got 1 here, plus 2i minus 2i, minus 4i squared gives me plus 4 over 2 times 1 plus 2i. So that gives me -4 plus or minus the square root of 36 over 2 times 1 plus 2i. Whoops. All right. So my two solutions are what? Well, W is either equal to -4 minus 6 over 2 times 1 plus 2i, or W is equal to -4 plus 6 over 2 times 1 plus 2i. Right, so we need to clean that up. We get -5 over 1 plus 2i. I've just about got the stylus working, but I've still got some problems with it, thinking I'm trying to tell it to change slide. So here we've got 2 over 2, so that gives me 1 over 1 plus 2i. All right, so the last step is to multiply those by their conjugates. So this is what I'm going to do on the next slide. And the same thing for this one. Right, so you probably have stopped watching by this point because this is very straightforward compared to most of what we've been doing, but I'll complete this now. So the denominator here gives me 1 plus 4. So that works out to be -5 over 5, so -1 minus 2i gives me my first solution, which is -1 plus 2i. And I do the same thing with the other one. So I've got w is equal to 1 over 1 plus 2i So again, the numerator works out to be 1 plus 4. We're just left with 1 minus 2i up here, giving me 1/5 minus 2/5 I. Okay, so there are my two solutions. So that's the first part of the question done. I don't think that's too bad, as long as you just apply the quadratic formula and don't muck it up along the way. And similarly, the second part, the loci part, is quite straightforward compared to some of the problems we've been doing in class in the last few weeks. So let's go back to the first slide and just look at that question now. Okay, so on a sketch of an Argand diagram, we want to shade in the region whose points represent the following complex numbers. Well, it has to satisfy both of these, the inequalities here and here. So this one is going to be a circle, and this is going to be a couple of half lines. And you'll see our old friend pi on 4 and negative pi on 4. Now, I suppose I should have done this using a nice GeoGebra grid, but I haven't done that. Never mind. So let's look at the first bit. So we want the locus of points that satisfies this equation. And we're going to start by rewriting it like this. So it's the modulus of z, take away 1 plus I. So if we want to draw that now, and this is pretty awful that I'm not using a ruler, but I want to get this done in a hurry so that you can watch it. The centre for my circle is going to be 1 plus I. So I want to find all of the points, z, such that the distance between z and this centre is less than or equal to 2. So we're going to draw a circle with radius 2. So this point is going to be 1 minus I down here, and up here this is going to be 1 plus 3i. I'm going to go out 2 here, and I'm going to go back 2 here. So my circle's going to look like this. I'm not doing a dotty line because this is less than or equal to, but we're not finished yet. So it's not all of the points inside that circle, so don't shade just yet. The second part is looking for this. So the argument of z is between pi on 4 and negative pi on 4. So arg z being equal to pi on 4 is a half line starting at the origin going out through here. Right, so we know that it goes through the centre of the circle at 1 plus I because we're looking for a 45-degree angle there. And conveniently, it's going to go through the point down here at 1 minus I. Right, so this is corresponding to this inequality, and the half line down the bottom is this one here. Remember that the argument is the angle formed by the point z and the positive direction of the x-axis. So the points that satisfy both of those inequalities are these ones in here. Okay, so that's what you want to be drawing in for that part of the question. Okay, so I don't know about you, but I feel like that's a much faster 5 marks to get than the first part, right? Because it just uses our straightforward locus questions. Thanks for watching. This video is already 9 minutes, so I'm going to come back and do question 10 separately.